so we have 6 questions from tutorial 6. Okay, let's go through one by one. We start with question number 1. Number 1, okay, consider the transformation T from R2 to R3. Okay, defined by this transformation. Okay, x, 2x minus y, 3x plus 4y. Okay, show that whether the function T is a linear transformation or no. Okay, so you have to prove the 3 condition, right? So the first condition is to show the 0 vector. Okay, substitute 0 to the transformation matrix. So 0, x0, y0. So you will get a 0 matrix. So this is okay. Condition number 2 is the addition of a matrix. Okay. So in this case, you have to let this transformation become 2 values. Okay. Let's say let u equals x1, y1, and v equals x2, y2. Okay, vector v and vector u. Okay, then t u plus v, this is equal to t x1, y1 plus x2, y2, right? x2, y2. Okay, so you can combine this x1 plus x2, y1 plus y2. Okay, continue to the next page. So your t u plus v is equal to just now x1 plus x2 and y1 plus y2, right? So refer your transformation value here. This is your x and this is your y. So now your x is x1 plus x2 and your y is y1 plus y2. So the transformation will become x1 plus x2 and then 2x1 plus x2 minus y1 plus y2 and 3x1 plus x2 plus 4y1 plus y2. Okay, this is your transformation vector. So now you can separate it. The first one is all x1 and y1, and the second one all variable x2 and y2. x1, 2x1 minus y1, 3x1 plus 4y1. The second one, x2, 2x2 minus y2, 3x2 plus 4y2. So, therefore, t u plus v is equal to tu plus tv, right? This is tu and this is tv. Okay, so you just prove the second condition. Let's move to the third condition. which is the scalar multiplication T K U is equal to T times K, and then your U will be X1, Y1. Okay, so this is Kx1 2Kx1 minus Ky1 3Kx1 plus 4Ky1. So KTU is equal to KTx1 Y1. This is equal to K times x1 2x1 minus y1 3x1 plus 4y1. And then when you multiply, you will get the same as the previous one here. So TKU is equal to KTU. Okay. So you just prove all the three properties. Hence, we can conclude that the function t is a linear transformation. Okay. Okay. Let's move to number 2. Sketch V and its image C under the given matrix transformation F. So this is the given transformation F and this is your V. Now we want to find C, where C is the image. Okay. So C is equal to the transformation 2002 times the matrix V minus 3, 3. We can say this is V. So write down the matrix minus 3, 3 multiply 2 times minus 3 plus 0 times 3, 0, 0 times minus 3 plus 6. Okay, simplify, you will get minus 6, 6. Okay, so this is the image C. Now you have to sketch the object V and the image C. Okay, sketch on the XY plane. X, Y. So for V minus 3, 3. Okay, here minus 3, 3. And for the image C minus 6, 6. Minus 6, 6. Okay, so the point here, this is C and this is V and C. V, C. So find the image C and then sketch in the XY plane the object V and also the image C. Next, number 3, the linear transformation T is from R4 to R2 defined by the equations K1 and K2. If V 8 minus 3, 2 minus 1, okay, find V prime. V prime is the image of V. Okay, so now let's write this in the matrix form. Okay, so you have two matrices K1, K2. So this is given by the value, 4 values times x1, x2, x3, x4. Okay, so the value will be, okay, the coefficient for each of these x1, x2, x3, x4. So for K1, coefficient for x1 will be 1, coefficient for x2 minus 3, coefficient for x3 0, coefficient for x4 4. So 1 minus 3, 0, 4. And then for the second equation, the coefficient will be minus 2, 5, minus 8, and 9. Okay. So after you write in the matrix form, you can substitute the value of V. Okay. These four elements of V, 1, 2, 3, 4 into this x1, x2, x3, and x4. Okay. So rewrite this. 8 minus 3, 2 minus 1. Multiply the matrix. You will get, okay, 8, 9 plus 9 plus 0 minus 4. Okay. Minus 16 minus 15 minus 16 minus 9. 5. So you can see here, this is the 2 by 4 matrix, right? And here 4 by 1 matrix. So your answer will be in 2 by 1 matrix. Okay, simplify your answer. 8 plus 9 minus 4. You will get 13. And solve this second row. Minus 16 minus 15 minus 16 minus 9. You will get minus 56. So this is your V prime. So V prime, V prime, V prime. Okay. Number 4. Use matrix multiplication to find the image of the vector 2, 5 when it is rotated in clockwise direction through an angle of 45 degrees. So there are several information here. So given this vector rotated in clockwise direction through the angle 45 degree. Sketch the vector and the image. Okay, so normally the standard matrix for the rotation will be given in your exam at the appendix at the back of your question paper. So if you still remember the here, okay, the rotation. Okay, given here is the counterclockwise direction. So if you want to find the matrix that rotation in the clockwise direction, you just change theta to negative, simplify it, then you will get this standard matrix. So we will use this standard matrix. So x and y is given by this standard matrix cos theta minus sin theta, and cos theta. Multiply with the given vector 2, 5. Okay, here. So the angle is 45 degree. So substitute the angle times with vector 2, 5. Okay. So use your calculator to find out all the values here. and then multiply with the vector 2, 5. So cos 45 degree will be 0.7071. Then minus sine 45 degree minus 0.7071. So just use the same values. 0.7071, 0.7071. So kira sekali je, you boleh dapat semua value. Kan, 2 kali je lah. Kira yang ni dengan ni saja, yang ni dia ulang balik je. So 2 and 5 multiply these two values, you will get, okay, what is your answer? Show me the answer and then sketch the vector and the image. So what is the answer? What is the image of the vector 2, 5 when it is rotated in clockwise direction through an angle of 45 degree? So your x will be 4.95 and your y will be 2.12. Okay, so now let's sketch the values. So agak-agak just assume the nearest value 4.95 and 2.12. Okay, so this is the image V prime. Atau kalau nak tambah pun boleh juga. Dia punya decimal 94971213. Okay. Let's move to question number 5. Define a linear transformation T from R2 to R2 with this transformation. Find the image under T of U and V. So you need to find TU and TV. Straightforward. TU equal to 1, 0, 0 minus 1 times vector U, 3, 1. Then you will get, okay, calculate the answer. And TV 1, 0, 0 minus 1 times vector V minus 1, 2. Then you will get, okay, very simple, because you have 0, 0 here, you can calculate it faster. 3 minus 1 and minus 1 minus 2. Okay, so now question number 2. Sketch U, V, TU, TV. Okay, sketch all this UV, TU and TV in a coordinate system and describe the transformation that happened under T. Okay, so I think I give you the wrong answer, right? For this, okay, make sure you correct your answer. Let's do number 2. The sketching. So this is your X and Y. Okay, label and then put the point U 3 1. Okay, 3 1. 3 1 will be here. This is your U. And then V minus 1 2 This is your V. And then the transformation TU3 minus 1 will be here. This is TU. And TV minus 1 minus 2. Here. Okay. TV. Okay, it's very simple, and obviously this is a to sketch is just a dot or a straight line. Oh, it's just a dot. The dot is enough. Here, I just want to show you the correct value here. Okay, it's 3 and 1. Okay, so you can understand. Okay, in exam it not necessarily to write down the line. Okay, the dotted line. The dot is enough. Okay. Okay, so here, what can you describe about the transformation that happened under T? It is a reflection at the x-axis. Okay, correct your answer. Reflection about the x-axis. Okay, so the transformation, it could be a dilation or contraction or maybe a rotation and reflection. Yes, reflection about x-axis. Okay, let's move to question number 6. Okay, ni okay. Okay, let A and W. Okay, matrices. Determine if W is in column A, is W in null A. It is in the column A if you can write it as a linear system, or the system has a solution. So W is in column A. Okay, first you can solve this using the REF, right? Okay, solve AX equals W. So your A minus 6 minus 3, 12, 6. Your X, X1, X2, and W, 2, 1. Okay. So let's solve this system of linear equation. So you want to change the first row. You want to change this to become 1. So let's divide this to minus 6. So row number 1, the operation will be multiply 1 over 6 to R1. So it will become 1 minus 2 and minus 1 over 3. And rewrite the second row and move to the next operation is to change this minus 3 to 0. Okay, how to change this operation for row number 2, R2, row number 2 plus 3R1. Okay, row number 2 plus with 3 times 1. So minus 3 plus 3, you will get 0. 0, and then for this 6 plus minus 6, 6 plus minus 6, you will get 0. And 1 plus minus 1, you will get 0. If you get all 0 rows at your matrix here, it means that this system has infinitely many solutions. Okay, so if your matrix has the solution, it means that this matrix W is in the column A. Okay, so in order for a vector to belong to the column space, it has to be a linear combination of the column vectors of the matrix. This means that the equation must have at least one solution. Okay, so here, okay, you want to solve this to show that it has infinitely many solutions. Okay, so x1, so from this equation, x1 minus 2x2 equals minus 1 over 3. So the second row here, all 0, so you can write x2 as a free variable. Okay, let x2 equals t. T is a free variable. Okay, so x1 minus 2t equals 1 over 3 minus 1 over 3. So x1 equals minus 1 over 3 plus 2t. Okay, so your x is equals x1, x2. This is equal to minus 1 over 3 plus 2t, t. Okay, so okay, all 0 here, all 0 row means that this system has infinitely many solutions. So W is in column A. Okay, so asalkan dia ada solution, then it is belong to column A. In order for a vector to belong to the column space, it has to be a linear combination of the column vectors of the matrix. Means that the equations must have at least one solution. Yes, W is in column A. Number 2, is W in null A? Null A, AW equals 0. Check whether you get 0 or not. Minus 6 minus 3, 12, 6, 2, 1, W, W to 1. So multiply minus 6 times 2 plus 12 times 1. minus 3 times 2 plus 6 times 1. Simplify. You will get 0, 0. So, W is in null E.